Hey everybody, this is Larry. This is day 4 of the new year, January 2025. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. And apparently we did it recently enough that it's in my cache or whatever. When did we do this? I guess like a year and change ago. I guess my cookies are just like, I don't know. It goes way back. Anyway, let's take a look at today's problem. We have 1930 unique Length-3 palindromic subsequence. Yeah, I'm back in New York. It's kind of chilly. I am slowly cleaning up my apartment. Not that you need to know that, but hopefully once I do that, I can clean up some stuff and maybe do more in-depth videos is why I would put it up. Okay, given a string S, we've done a number of unique palindromes of length 3 that are a subsequence of S. Okay, note that even if there are multiple ways to obtain the same subsequence, it's still only counted once. Okay. Yeah, I mean, I think that's... Okay, yeah. So, I mean, the key thing to note is that for this problem of length 3, there are only 26 square number of palindromes, right? So that means that in theory, we should be able to check all 26. Right? Oh, sorry, or 26 square. N is 10 to the 5th, so you have to be a little bit careful, I suppose. But because you cannot do like n times 26 square or something like that. Or I guess just n times 26 should be fine, actually, right? There are a couple of ways you can. There's definitely a lot of ways you can do it. But I'm just thinking through in my head. Maybe 26 times n is fast enough, where n, or 26 is alpha, where it's the size of the alphabet, right? But maybe we can even do a little bit better. I don't know. I think it's kind of funny because the way that I want to solve this is the way that the last weekly, or maybe it was bi-weekly, the bi-weekly contest from 2 weeks ago, because I just did it very recently, where it's the same idea of just enumerating all the things. Yeah. Yeah, and I don't know. I don't know what is the best. I don't know. I mean, I think there are a lot of ways you could do it, but the way that I would think about it is with sweep line, right? And here, maybe you could kind of think of, let me bring up the drawing thing for a sec. The way that I would maybe think about it today is something like, okay, so we're given, you know, an array of stuff, and this is the line that we're sweeping. So basically, and the line that we're sweeping is at an index, so you have maybe some character X, right? So then now you're trying to look at all the previous characters and all the future characters and just see what exists from A to Z, and then that's it. That's all there is, right? And you just have to keep track as you sweep from left to right, right? So yeah, that's basically the idea I want to do here. Yeah, and basically so the right side is going to start off with basically everything, right? And then now for and then left is going to be just empty, right? Yeah, and then now for I in range of S or N, sorry. So then now S of I is the middle character. So we do 2 shifts really. We do from right to S of I, and then from S of I minus 1 to left, right? So yeah, yeah. So that means that right of S sub I, we subtract by 1, right? And then left of S sub I minus 1 we increment, but of course you have to check that, you know. Right, but yeah. And then now we just, there are a number of ways you can do it, but you could just go through all the characters. So maybe just like for so maybe we have like a scene thing for a set, And then now for character in left.keys, right? And if it's in the left, then we just have to check that it is in the right. If right of C is greater than or equal to 1, or just greater than 0, I suppose, then now scene we can add, because then now this character is on the left and on the right, so then we can make a palindrome with the number, with the character in the middle. So technically it's just C plus S of I plus C, which you don't have, I mean, which you can normalize a little bit even to this, and that would be fine. And then that's it. There should be n times alpha, where alpha is 26, but which, I don't know, Leetcode does do some crazy things sometimes. And when I click on 1, why does it go back up? But yeah, let's give it a quick submit, see if that works. And yeah, it looks okay. I mean, it's a little bit on the slower side, but that's okay. I'm lazy today. Can we optimize, right? I mean, obviously you saw me do this, and you know, it is like a 4-minute thing or 3-minute thing for me to type this up. But we want to optimize a little bit. Can we do it a little bit more? I mean, there are some things that you can do with like bit masks, for example. If we do bit masks, then this will be a lot quicker, right? We can, okay, let's do that for now, right? So then we can do this check really quickly. Yeah, maybe you have a left mask is equal to 0, and then right mask is equal to, well, we have to set it up. So let's just say 0, but then now for C in right.keys, we do right? And this is just bit mask stuff, which is just like a Boolean table, really, but when in one number, right? So then now here, when we add a thing, then left mask, we do 1 right? S of I minus 1 minus ordinate of A, and then here we want to subtract. So then now if right of S of I is equal to 0, then we take it out, right? So then yeah, right? There are a couple of ways you can do it. I guess I'll just flip it. Right, so something like that. And then now here, I guess you still need the for loop though. So I mean, you're able to get I mean, no, I guess you don't have to, but you have to at some point. I guess that's not true. I mean, you could definitely do it, because what I was going to say is that then now left mask and right mask is going to give you all the things, but then in theory you have to iterate for it to add it to scene. But you also could just yeah, you can also just say like you could set up a funky data structure of middle is equal to say 0 times 26. So this is the middle character and what's on the left, and then middle mask, maybe you would call it that. But that's kind of crazy talk, really, honestly. So the middle mask of S of I minus right, is then now we can or this thing. So then now, yeah, and then that basically gets us all the masks. And then now all we have to do is just count up all the bits. I forget how to, like, so then now for X in middle mask, we can actually just do yeah, like, oops, right, and then we add it by like x dot bit count or something. I think that's the thing, right? And then that should be in theory good, but you know, we did a lot of stuff about testing, so there probably is a lot of silly mistakes here. Middle mask S sub I is S sub I, right? Yeah. Order sub A should return a number. String and int. Oh, I have to. I am dumb. I have to do all this stuff. I forgot. That's the one thing about Python that's a little bit sloppy sometimes. I mean, of many things. I'm sloppy on many things, but that's one of the things. Okay, so that looks okay. Let's give it a quick submit. And yeah, now it's much faster. But that's just like bitmask optimization, you probably could do a little bit better. I don't know. Can I click on this? Oh yeah. Well, okay. I guess they just use C things, but yeah. I don't even know how this works. What did I click on? I guess the find functions are cheap, but yeah. I mean, I think the idea is just kind of also try to observe it in a way that is you know, that allows you to solve more difficult problems, right? I mean, sometimes especially when these problems are a bit on the easy side, like it's okay to solve it specifically, especially on a contest. But if you have time and you want to upsolve, then, you know, you want to play around with techniques that you're not just, you know, as good at doing normally. But yeah, that is all I have with this one. Thanks for watching. Have a great weekend, everybody. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.